Hi everyone, welcome to today's class. Today we have a kind of a rhetorical math challenge. Okay, this is Singapore Math Olympiad question. And anytime you see me dressed like this, anytime you see me button up the last button, you just know that the question we have at hand is not an easy one. But despite it's not easy, we're going to solve this Math Olympiad question. Okay, Singapore Math Olympiad question. It's a math challenge for men, not for children. All right, so if you're new here, this is Online Math TV, where we roll out mathematical challenges all the time. If you've not subscribed, do where to subscribe. Okay, and when you subscribe, turn on the notification bell so that you get notified whenever we drop an amazing video like the one you're about to watch right now. So let's go into today's challenge without much waste of time. All right, so from here, we take selection. Look at this radical equation carefully. It says the square root of 1 plus 20 all over x minus the square root of 1 plus 24x equal to 2. So how do we solve this? Like I said, this is a rhetorical question, and it took me some time before I was able to figure it out after much research. All right, so now look at the first thing I'm going to do, because this is a radical, this is a radical. So the first thing we do is to move this to this side of the equation. Okay, so if we do that, so we're going to have here the square root of 1 plus 20 all over x equal to your 2 plus the square root of 1 plus 24x. Easy, right? Well, now we want to eliminate this radical. So what we do, we take the square of both sides. So we rule this bracket, this all to the power of square. We take this also all to the power of square. Now you know this doesn't have issues, so this and this leave the system. We want to open this. I could as well have gone ahead to just bring the result to this, but I'm going to simplify this step by step here. All right, so let's keep this right-hand side, left-hand side of the equation. Rather, this is equal to, we can write this as 2 plus the square root of 1 plus 24x, right? Bracket, your 2 plus the square root of 1 plus 24 is 24, please, x. Then let's close our bracket. So let's go ahead to open this systematically. Okay, so when we open this will give us here, this times 2 will give us 4. 2 times this will give us plus 2 root 1 plus 24x. Then we come to this term, this times 2 will give us 2 into the square root of 1 plus 24x. Then we use this to times this will give us plus bracket the square root of 1 plus 24x, all right, all to the power of 2. Easy. We are going systematically, all right, and so we can add these two together, and this will leave. So let's bring our 10 down here. So if we bring this side down, we'll have here 1 plus 20 all over x. This is equal to, here we have 4. This together will give us plus 4 into the square root of 1 plus 24x. Then plus, here we're left with 1 plus 24x. Easy, right? So what we do here now, let's keep only this radical term on the right-hand side and move every other term to this other side. Now, before doing that, let's just go straight here. Now, here we have 1 and here we have 1. So this and this will leave. So this will stand on this. So we have 20 all over x. Then we can move this to this side. So this will give us minus 4. Then this to this side will give us minus 24x, everything equal to 4 into the square root of 1 plus 24x. Easy. Okay, so now let's look at this together again. Now, if you look at this, 4 are going to this, 4 are going to this, 4 are going to this, and we have 4 here. So let's use 4 to divide through. If we use 4 to divide this will give us 5, right? So we have here 5 all over x, then minus 1, then minus 5 here will give us a 6x equal to here we have square root of 1 plus 24x. Again, let's eliminate this radical. So we take the square of both sides again. So we square this, we equally square this. Again, the right hand side doesn't have issues, so here we have this leaves. So let's expound this like we did here. Okay, so what we did here, let's do same thing here. So let's come to this side of the bird and rule out this. Okay. I also have here 5 all over x, then minus 1 minus 6x into itself. So we have 5 all over x minus 1 minus 6x. Then everything equal to, here we now have this equal to your 1 plus your 24x. So let's multiply again. This times this will give us 25 all over x squared. This times this will give us minus your 5 all over x. Okay, this time this will give us minus 30, right? It's 30. Then we come to this minus 1 times this will give us minus 5 all over x. Minus 1 times minus will give us plus 1. Then minus 1 times minus 6 will give us plus 6x. Now for this, let's come to this side. So minus 6x times this will give us here minus 30. Okay, minus 6 times this will give us plus 6x. Then minus 6 times minus 6x will give us plus 36x squared. Everything equal to 1 plus 24x. All right, so what we do here now, let's sum up everything on this side. Now let's see. Then here we have 25 all over x squared. So here remain 25 all over x squared. Then minus 5 all over x minus 5 all over x. This will give us minus 10 all over x. Then minus 30 minus 30 will give us minus 60. Then plus 1. Do we have any other number? No number. Oh, so this and this will leave. Okay. Then your 6x plus 6x here we have here plus 12x. Then here we have plus 36x squared. Everything equals to 24x. Oh, this is good. So let's look at this again. Let's make the right hand side to be 0. So move everything to this side. So if we move this to this side, this will give us minus 12x everything here. So therefore, we are not going to have 25 all over x squared, then minus your 10 all over x minus 60, then minus 12x plus your 36x squared equal to 0. All right, so from here, I'm going to rearrange this challenge because this is where the beauty of this radical equation comes in. All right, so from here, I can write this as your 5 all over x all to the power of 2, right? I can equally write this as 6 to the power of 2, right? Good. So minus, if I bring here 60, then I bring here, look at this thing I'm having here. I want to get something like that from here. So I'm going to write this as your 10 all over x. Then I bring this together minus 12x, okay, plus 6x all to the power of 2 equal to 0. This is square, this is square. So I want to bring this and this together. But before that, if you look at this, we can get similar quantity like this from this place. So what we do, we are going to factor this or group this one and factor out 2. We discover that we are going to have something like this and this out. So thus, we're going to have here 5 all over x r to the power of square minus 60, then minus here, we're going to bring out 2. So here we have 5 all over x, then plus 6x close bracket, plus your 6x, the r squared equal to 0. You get that? Good. This is where comes the beauty of this radical equation. Now, with what we're having here now, I want to rewrite this minus 60. So I want to bring in 120. So minus 60 could also be written as plus 60 minus 120. That will give us minus 60. So rewriting this place here to be plus 60, then minus 120, we have to multiply by what we have inside here and inside here. Okay, the coefficient, which is 5 all over x and 6 all over x. That when we multiply out, it will give us our plus 60 back. That is the manipulation. Okay, so from here, we're going to have this, or this now implies that our 5 all over x r to the power of 2, then plus our 2 into 6x bracket 5 all over x close bracket minus 2 bracket 5 all over x plus 6x close bracket, then plus our 6x r to the power of 2 minus 120 equal to 0. Confused? Now look at what I did at first. I brought this and this together and I substituted a particular alphabet for this and for this to form a quadratic equation with 60 minus 60 being the constant. When I solved that, I did all within my power. I did get this solution. Until after much research that yes, I have to eliminate this quantity here, and how I must multiply or look for a way to multiply this term here and this term here together, and then it will now leave the system, leaving me behind this, and this. Okay, so you discover that if we open up this expression we have here, this will still give us our plus 60. Right? And we know that plus 60 minus 120, that will give us minus 60, which is what we have here now. So it has not really changed the system. So doing this, the whole of this system leaves the game and we can bring this and this. So thus, this now implies that our 5 all over x plus 6x r to the power of 2, then here minus your 2 into your 5 all over x plus 6x plus bracket minus 120 degree equal to 0. So what we have in here and what we have in here are the same. So let's quickly bring in another alphabet to represent what we have inside the two brackets since they are the same. So let's continue on this side of the board. Let's bring in another alphabet. So from here, let's say let's use t be equal to what we have inside the bracket. So we have here 5 all over s plus 6x. So wherever we see this, let's put in this. So automatically we're going to have here, or this now implies t squared minus 2t minus 120 equals to 0. Now this is a quadratic equation, so we have to solve this quadratically, and we look for two factors from 120 that we will multiply together will give us minus 120, add together to give us minus 2. So that will give us plus 10 minus 12. So this automatically will give us t squared, the plus 10t minus 12t minus 120 equal to 0. So we can put this in bracket, then put this in bracket. What is common here is just t, so we have here t plus your 10 close bracket. What is common here is 12, so minus 12 bracket. Here we give us t, minus will give us plus. Then here we're left with 10 equal to 0. So we take this one outside with this and one of this inside. So from here we have here t minus 12 close bracket, your t plus 10 equal to 0. So therefore we now have our t is equals to positive 12, or here will give us what? Minus 10. So these are the value for our t. Though we now recall where we said let t is equals to this. So look for case 1, case 2. Okay, so for our case 1, we have t is equals to 12. So we'll now take our case 1. So we have here case 1. So what is case 1? We are taking t is equals to 12, which is equals to, but let's say let t be equals to this. So we have 5 all over x plus 6x, right? So we remove this denominator here. So let's continue on this side again. All right, so clearing up this will now give us here, this now implies 12x equal to 5, then plus 6x squared. So if we rearrange, this will give us your 6x squared, okay, then minus 12x, then plus 5 equal to 0. Now this is a quadratic equation, so we have to solve quadratically. Now solving quadratically, can we use factorization method? All right, no, so let's use the quadratic formula. So this will give us x is equals to minus b plus minus the square root of b squared, then minus 4ac. Okay, let's cover it well, all over 2a. We just have to bring our a, b, c out from here. So we have a is equals to the coefficient of s squared, b is equals to minus 12, and c is equals to the constant term 5. So let's substitute this into our formula. So we have x is equals to minus bracket minus 12 close bracket plus minus the square root. All right, minus 12 to the power of 2, then minus 4 into a is 6 into rc is 5. All right, everything all over 2 into 6. So this is equal to, here we have positive 12 plus minus the square root. This will give us 144. Then minus this will give us 30, 120. So we have 120. All right, everything here all over 12. So again, we factorize this. This will give us 24. So we have here 12 plus minus the square root of 24 all over 12. Again, let's continue on this side. I told you that this Singapore radical equation is a tough one. So 24 can be expressed as 4 times 6, right? So let's quickly express this. This will now give us here your 12 plus minus square root of 4 will give us 2. So we have 2 into the square root of 6 all over 12. So we can factor out 2 from here. This now implies our x equal to, here we give us 6 plus minus root 6 all over your 6, right? Yeah, all over 6. Okay, so we have 2 solutions from here now. So here we're now going to have here x1 is equal to, we can break this down to give us 6 plus your root 6 all over 6. Now, when I substituted this very root into our original equation, it didn't satisfy the equation. And so this answer is rejected. This one is rejected, please. Okay, so this one is rejected. So let's look at x2. So our x2 will give us 6 minus square root of 6 all over 6. So if we simplify this down, then x2 is equal to, here we have 6 all over 6 plus root 6 all over 6. So therefore we have our x2 is equal to 1 plus the square root of 6 all over 6. Now when I put in this answer into the original equation, it satisfies the original equation. So x2 satisfies our original equation. Please, sorry, don't mind me here, it's minus. Sorry, please, this minus. Pardon, please. Minus. Okay, so when I put this into this challenge, it satisfies the original equation. So now let's look at case 2, where we have So we have here case 2, case 2, where we have our t equal to, what is our t? Minus 10. So t is equal to minus 10. And we said t is equal to what this? So this is equal to 5, right? All over x, then plus 6 x. All right. So from here, we clear this x denominator here. So if we clear this will now give us minus 10x equal to 5, then plus 6x squared. All right. So again, let's rearrange. So if we rearrange this, we're going to have this to be our 6x squared, right? Then plus your 10x plus 5 equal to 0. Again, this is a quadratic equation. So let's continue on this side. I told you that this Singapore radical Math Olympiad question is a very crazy one. You can see I'm sweating furiously, but we'll get to the root of this. Okay. All right, so we use the quadratic formula again. So we're going to have x is equal to minus b plus minus to the square root of b squared minus 4ac all over 2a. So this is our a, this is our b, and this is our c. So automatically we have this to be minus 10, right? The plus minus the square root of your 10 squared minus 4 into 6 into 5, right? Good. So everything all over 2 into 10, right? All right. Sorry, into 6, please. Into 6. All right. So here we have here minus 10 plus minus the square root of 100 minus this will give us 20, 120. So we have 120 all over your 12. Okay, so if we subtract this from this will give us minus 20, right? So we have this to be minus 10 plus into the square root of your minus 20 all over your 12. Again, we can write your minus 20 as minus 1 times 4 times 5. And the square root of minus 1 is iota. Remember that the square root of minus 1 is equal to iota. So rewriting this, automatically we're going to have your minus 10, then your plus minus your 2 iota into the square root of 5 all over your 12. So we can factor out 2 from here. So let's continue on this other side. We are almost there. So we're going to have our x is equals to 2 into this will give us minus 5 plus minus the 2 we cancel out this, so we have iota into the square root of 5 all over 6. So we have our x2 is equal to this will give us our x3, please. So our x3 is equals to minus 5 plus iota into root 5 all over 6. x4 is equals to minus 5 minus iota into root 5 all over 6. Okay, this. All right, as for these two roots, in fact, you can go and check by yourself and see if they correct or they satisfy the given radical equation. At least I'll try my best. Okay. All right. So I believe this will satisfy this radical equation. Oh, my goodness. Wow. All right. So this brings us to the end of this Singapore Math Olympiad challenge. If you learned something from this video, drop it in the comment section. If you have a better way of solving this challenge, please do not hesitate to drop it in the comment section, because we equally want to learn from the best brains all around the world, professors, doctors in the area of mathematics. Okay, so you have a better way of solving this, conserving time. Drop it in the comment section so that we can equally learn from you. Remember, I love you. And again, if you've not subscribed, do well to subscribe. I love you, because they are always there. Bye for now.